We now determine the components of a vector perpendicular to both p vector and q vector. So here we are given p vector equals -1, 3, and 0, and q vector is given as 1, -5, and 2. So to find the vector which is perpendicular to both this vector, we find the cross product of these two vectors. That is, we do p vector cross product with q vector. And so this equals the cross product of any two vectors we can find using the determinant. In the first row, we write the vector components I, j, and k. Basically, these are unit vectors. And in the second row, we put the first vector, that is p vector. So here we put -1, 3, and 0. And in the third row, we put the components of the second vector, which is 1, -5, and 2. So we have to evaluate this determinant. So now let's evaluate this determinant. I'm going to expand along the first row. So this equals, I put this unit vector I vector, and then we have to multiply with 2 by 2 determinant by leaving the row and column represented by I vector. And so we will get 3, 0, -5, and 2. Then we put this negative j comp vector, and then multiply this with the 2 by 2 determinant, leaving the row and column represented by j vector. So you will then have -1, 0, and 1, and 2. And similarly, we do for the k vector. So this will be multiplied with the 2 by 2 determinant, that is -1, 3, and 1, -5. Now let's evaluate each of these 2 by 2 determinants. So this equals I vector. We should take the product of the diagonal minus the product of the cross diagonal. So here this will be 3 times 2 is 6, negative, -5 times 0 is 0. And then I put j vector. So once again we take the product of the diagonals minus the product of the other diagonal. So this becomes -1 times 2 is -2 minus 1 times 0 is 0, so it is 0. Now we do the same thing for k component. So product of diagonals minus product of the other diagonal. And so this gives -1 times -5 is +5 minus 1 times 3 is 3. Let's simplify this. So this equals I vector times 6. And here we have -2, but we already have a negative. So product of two negatives is positive. So therefore this is 2j. And this one is 5 minus 3 is 2. So it is 2k. Now we can write this in component form, that is in bracket form. So we put only the components. The I component is 6, j is 2, and k is 2. And so this is one of the vector which is perpendicular. Vector, this is perpendicular to both the p vector and q vector. In fact, we can also determine one more vector which is also perpendicular to both vectors. So that will be q vector cross p vector. Its components will be exactly the same, but it will be negative components. So this is one such vector. Now let's do part B. Here we have the two vectors. M vector equals 1, 3, -4, and n vector equals -1, -2, and 3. So let's find a vector which is perpendicular to both these vectors by taking the cross product of these two vectors. So I write m vector cross product with n vector, and this equals determinant. So in the first row we put the I, j, and k. The second row, we put the first vector, that is m vector. The components of m vector is 1, 3, -4. And in the third row, we put the components of the second vector in the cross product, which is n vector. So it is -1, -2, and 3. So we have to evaluate this determinant. We can expand it along the first row. This equals I vector times the 2 by 2 determinant leaving the row and column represented by a vector. So we will have 3, negative 4, negative 2, and 3. Then we put negative j vector. Then multiply this with 2 by 2 determinant leaving the row and column represented by j vector. So we will have 1, negative 4, and negative 1, 3. And also we do for k vector. It is k times of 1, 3, negative 1, negative 2. Let's evaluate each of these 2 by 2 determinants. So this equals I vector times the product of the diagonals, which is 3 times 3 is 9. We then put minus the product of the other diagonal is negative 2 times negative 4 is positive 8. So I put 8 here. And then we have negative j. And here we have the product of the diagonal is 3. We then put minus the product of other diagonal is positive 4. Then we put k vector times the product of diagonal is negative 2 minus the product of other diagonal is negative 3. So this is negative 3. And so this gives I vector 9 minus 8 is 1 minus j vector 3 minus 4 is negative 1. So this will be positive 1. So I'm going to write this as plus j times positive 1. And then we have plus k times, this one is negative 2. This is positive 3. Negative 2 plus 3 equals 1. So it is k times of 1. And so we can write down the components in the vector component form, that is in bracket form. The first one is 1, second component is 1, third component is also 1. And so this is the vector perpendicular to both m and n vector.